Differentiation of simple trig functions.
Okay, so today we want to look at differentiation of simple trigonometric functions. Simple trigonometric function, how to find the derivative of simple trigonometric functions. So we have functions like y is equal to sine of x and y is equal to cos of x. If you have a function of this nature, and also if you want to look at y is equal to sine of ax, sine of ax. If you have functions of this nature, this simple trigonometric function, and we want to find the derivative of this function. One, so dy dx of sine of x, of a function sine of x is always equal to what? Cos x. Dy dx of a function sine of x is always equal to cos x. 2. Sorry, the ddx of a function y, which is cos x, always give us negative sine of x. So when you differentiate sine x, you get positive cos x. When you differentiate cos x, you get negative what? Sine x. And 3, when y is equal to sine ax, so the derivative of the sine of ax is simply what? You put the a out, you differentiate the sine, the x over here, which is what? The a here, and you multiply it by what? The sine of. So the a here now becomes multiplied by the derivative of what? The sine of what? Of the x. I get it, which is equal to a what? Cos x. So anytime you have y is equal to ax and you want to find the derivative, you get what? A what? Cos x. Let's take two examples here. So first example, you have y is equal to sine of x squared minus 2x plus 1. You have to find dy dx. Find dy dx. Find dy dx. So now what happens is that if you want to find the y of a sine function, so let's take this whole function, x squared plus minus 2x plus 1. You have to find the derivative of this whole function before you can find the x of what? Of this function. So you have to take note of that because, sorry, the question here is minus 3x. Okay, so now when you do this, you get a cos of what? Cos of what? Of x. But take note that the a was a constant, so you find the derivative here, and you have to put what? The ax over here again. I get it. So the derivative of sine ax is equal to a cos of the ax. Okay. So now what you get here is that you have to find the derivative here, because here the derivative of what? The x, the ax was what? Was a. So you find the derivative here, and the y, the x here will give you what? The function here will give you 2x minus 3. So since you are getting that function here to 2x, then the dy of the x, so d of what? Sine of x squared minus 3x plus 1 is therefore equal to what? You find the derivative of what? The x values over here, and that's why we got it as 2x minus 3 cos of what? What is over here, which is what? X squared minus 3x plus 1. So this is the derivative of what? Finding y equal to sine x on that. Now let's take one more example. If we have y is equal to cos x plus sine x, and you have find y dx, derivative of cos x is always negative sine x, plus derivative of cos sine x is always what? Cos x. And this will be your answer. And the last example, if you have y is equal to 3 minus cos x, 3 minus cos x, we want to find it, the dy, the x, anytime you find the derivative of a constant 3 is 0. And find the derivative of minus cos x. So it's minus cos x, that will give you positive what? Sine x, which is plus what? Sine x. So therefore the derivative dy dx is equal to what? Sine of x. Try your hands on this in the house. Try your hands on this one. Find the derivative of y is equal to 3 cos of 5x squared plus 2. 3 cos of 5x squared plus 2. Thank you for joining this video. Let's meet in other lessons.